Okay, may hapon natong tanan now. So I have to discuss now on how to find the differential equation of a given family of curves. Okay, so we are given some hint no on how to solve the dA of the family of curves. No, so draw the figure from a given condition showing maybe three members if needed. No, and have the equation of the family of curves. No, and from the equation of family of curves, so you have to identify which constant can be classified as arbitrary and which constant can be classified as a fixed constant. Now, obtain the dA by eliminating the arbitrary constants and simplify the results. To recall, we have two types of constant. First is the arbitrary constant. These are constants which can be found in a solution whose values can be obtained from sets of boundary conditions. Their solutions are different in members of the family of curves. So, this constant will be eliminated, no? So, in the differential equation form, so this constant will not be present anymore. Okay, so number 2 is the fixed constant. The fixed constant is a parameter not to be eliminated and can still be found in a differential equation of a relation. Their values are common in all members of the family. Okay, so in order to make this topic easier for us to understand, now just recall the equations common curves, no, like lines, conics, or a second degree curves like circle, parabola, ellipse, and hyperbola, including the differentiation process and rules of differentiation. Now, if we are asked to find the differential equation of the following families, okay, first, when you are given a family of parallel lines, what is their differential equation? Okay, so I have to start with a figure. Okay, so I have a line constructed. So other lines will run parallel to the first, then second. So we have actually four members of the family of lines. No? Now, we recall that lines are parallel if their slopes are equal. Correct? So, provided they are not coincident, no, they are separated with a constant distance. So, more importantly, for us to observe, no, that their slopes must be the same according to our analytic geometry. Okay? Now, I have to consider an equation of lines, no, wherein there is an presence of a slope, no? So, what equation of line, no? So, we have maybe on sa slope and intercept form. So, this is the slope, no? So, and then B represents the y-intercept, no? So, if the lines are parallel and their slopes are equal, no? So, that means ang imo karong slope is the same in all members of the family. Say, the slope here is 2. So, all members have the same slope. No? So, M here is common in every member of the family. But try to observe, no? If you have your y-intercept, your line crosses or passes through different point on the y-axis. So, we know that there is a y-intercept of every line, but ang atong y-intercept in a member of the family is actually different from the other. So, if we have to identify which constant is a parameter and a fixed constant, ang fixed constant is a constant that is common in every member of the family. No? So, that means, ang imo karong M mao imuhang tawgon og sa fixed because that is becoming common in every member of the family. Okay, your B, ang atong B mao na atong tawgon sa arbitrary. So, in finding the differential equation, after knowing that your B is the arbitrary constant, so you already have the idea that there is one arbitrary constant and you need to differentiate only the function once to eliminate your B. Okay, and it's good that your B is isolated. No? So, if that's isolated, then by differentiating it with respect to x, then you can have the y prime which is equal to the slope. So, in a line, when you differentiate your line, it is always m that is left. Now, why? Because we know that the derivative represents the slope of the curve. And in a line, the slope is constant. So, when you take the derivative of the line, then what is left is always the constant slope. Now, in differential form, being a first order, first degree D, actually okay na ni as an answer. So you can also write that in a differential form. So y prime is also a dy dx, no? So we can have the dx multiplied with m. So m dx minus dy equal to 0 as our answer if expressed in terms of a differential form. Now, if ever we have to interchange, no, allowing our b to become fixed and our m as the arbitrary, so the condition of the problem will be like this, no? Lines passing through a fixed point at the y-axis, no? So that is the family of curves that is being described. So I have to draw members of the family. So at the y-axis, no, if this is a point at which one line will pass through, then other lines will also pass through the same point at the y-axis, no? So the y-intercept is a point, so you can assign coordinates if you like, no? So being at the y-axis, the abscissa is 0, the ordinate is b. Actually, your b is the y-intercept. So you have two options, no? What equation of line are we going to use, no? Now, ang ato diang y-intercept dire, that's common in every member of the family. So ang ato karong b, mao na karoy mahimo ang sa fixed constant, while the slope of your line, considering that every line have different angle of inclination, it also follows that ang atong slopes are also different, no? So you have two equations of lines in standard form that we can adapt, no? That we may adapt in our solution, no? So because there's a point, pwede ka mo gamit og point slope form, and because we also have slope and intercept mention, so pwede sa ka mo gamit og slope intercept form, no? Now if you have to use the point slope form, the point considered is the point on the y-axis with x1 equal to 0, your y1 being equal to b. So may puli dire, and mo resulta na mugawas ra pa ng y equal to mx plus b. So I may have the slope intercept form be taken directly. So we have y equal to mx plus b, and your m here will come out to be an arbitrary constant, no? Because it is changing the value of the slope is actually different from the other member of the family. Ang atom b is the one which is fixed. Okay? So eliminate m, no? Okay. So when you differentiate, no? So you only need to have a first order differential equation considering there is only one arbitrary constant. Okay, so taking the derivative of your equation with respect to x, so y prime is again m. We are supposed to eliminate m, but in the first derivative of the function, it is m that is left in the equation. So this cannot be an answer yet, no? So I have to use my equation, no? The equation of the family and the equation obtained after differentiation. I have to substitute this to my y equal to mx plus b, replacing my m with a y prime. Okay, so we have y equal to y prime times x plus b. Rearranging the term, no? So doon ay mga term ng y derivative like y and b, so we group them, no? I try to group them. So this is a term free from derivative, and in differential form, this is the one which will be a factor of the dx. So y minus b times the dx, okay? Then minus x dy if we let the right side be equal to 0. And this is now your answer for number 2. Now, number 3, if we have lines with slope and x-intercept equal, actually, pwede ka mag-graph, no? Mag-present sa imong family of curves, or if you can go directly to the equation without the graph, it is still okay. Basta try to identify unsay mga arbitrary, unsay fixed constant in your equation of family of curves, no? Okay, so here is the solution. It would be good if there is a graph, no? Now, if your line has an x-intercept of 1, the slope must also be 1, no? Okay, so this is a line maybe having an x-intercept of 1, y-intercept is also 1. If this crosses at the x-axis minus 1, so meaning the slope is also equal to a negative 1, okay? Say, kana doon na slope nga, negative 1. Kanini, agi siya at 1.5 or 3 halves. So, the slope is also 3 halves. Okay, so, if I'm going to consider a point on the x-axis, well, the coordinates of the point is the x-intercept and the ordinate is 0 being a point at the x-axis, no? So, I can use what equation? If there's a point, every line has a slope, correct? So, pwede ko mo gamit og point slope form. Okay, so using the point slope form, I can change my y1 and x1 with the coordinates of a point on the x-axis for a specific member of the family. Okay? So, y minus 0 and m times x minus a. Okay? But there is a further condition that the slope and x-intercept are equal. So, that means a is equal to m. So, I can change my a to m. Okay? And this is my equation wherein I'll be solving for the dE. Okay? So, the equation of the family of curve. Again, when you differentiate this, you will always arrive with y prime which is equal to m. But m needs to be eliminated. There is only one arbitrary constant, which is m. So, the order of my dA is only a first order. So, I have to go back to the equation number 1, replacing again my m with a y prime. So, this is now the resulting equation. So, we have y equal to m, which is now y prime. So, replacing again your m with y prime. Okay, and distribute, we have on z. Okay, so, we have y equal to xy prime minus y prime, or the square of y prime. And this is now your answer. First order. How about the degree? The degree is 2. Okay, so this is a differential equation. So, I don't need anymore to write this in a differential form because this is not first order, first degree D. So, you can take this as your answer. Now, in number 4, you have circles with center at the y-axis. Okay, so I can draw members of the family. So, you have circles of different radius because once I mention of radius, no, whether it's fixed or not. So, it should be at a variable radius. Okay, so makita nimo line-line of sizes itong circle. What is important there is that the center is located at the y-axis. Mentioning that the center is at the y-axis, so you have the idea on the coordinates of the center. At any location, the coordinates of the center can be h and k. But being at the y-axis, the abscissa must be 0. Okay, and there is an ordinate k because there is a distance from the x-axis vertically to the point. And that is true to other member of the family. So, mapili lang kag usa ka member, assign the coordinates of the center, and relate that to the equation of the circle. Now, equation of the circle can be expressed in a general form. This is general form. And since we assign the coordinates of the center, so it would be good to use the standard equation of a circle involving h and k as the coordinates of the center. When the center is at the origin, so your equation is simpler, no? With r as the constant. Okay, so kanang x and y are the coordinates, are the moving point, no? Okay, so C. Okay, so this is my equation. Okay, so the center coordinates atong ipuli diri. So my equation can be, what's my equation? X minus 0, okay, for the first term, in square plus y minus k, then square equal to r squared. So, equation, first term is now x squared. Then y minus k. Okay, the quantity y minus k squared is equal to r squared. Now, there are two constants left. Okay, and there are no relations mentioned between k and r. No? So, that means the arbitrary constants are k and r. So, I have to differentiate my equation number 1 twice. No? Okay. Differentiating it for the first time. Okay, so we have 2x plus 2 under a power rule, no? Times y minus k. Then derivative with respect to x of y is y prime. K is eliminated. Yes, for the when we take the derivative of our u under a power rule. And r squared is totally removed because r squared is an isolated term. Okay, to simplify, I have to remove by dividing each term by 2. And this is my resulting equation. Now, I need to eliminate my k. Now, by differentiating further. Now, k is not an isolated term. Actually, you can differentiate directly. But you can also plan on how to eliminate k directly by isolating it. Now, you can isolate your k if you divide with y prime. Okay, so try to divide with y prime each term. And this is now the result. X over y prime plus, okay, this is now y minus k. So, it is already expressed as a separate term, no? So, differentiate using a quotient rule for the first term and apply the appropriate formula for the second and the third term. Okay? Quotient rule is applied in the first term and this is the result. Square of the denominator. Then, we have the denominator derivative of the numerator minus x. Then, derivative of the denominator. Y prime now becomes the y double prime. Y becomes y prime and k is out. That is becoming 0 when differentiation is applied. Removing the denominator, okay, so we have a product of the square of the y prime with y prime, so this becomes cube. Okay, the numerator are collected. Okay, so these are now the terms of your answer. Okay, so that is problem number 4 related to problem in circle. Okay, this is number 5. Circles, okay, tangent to the x-axis, okay, with a fixed radius of r. Okay, so you'll notice that all circles have the same sizes because the radius is actually fixed. Now, I try to locate the center of one of the circle and I can assign the coordinates of each k. Is there a value of h? Yes, there is. Okay, different from the distance here. So, ang h ni Mona can be arbitrary. What is the use of mentioning? By the way, this is a radius, correct? And at the same time, this is your k. Because nag-mention man siya ang imong circle is tangent to the x-axis. So if that is tangent to the x-axis, so this is your r. At the same time, that is your k. So your k is equal to r. So if you consider the equation of the circle, which is this one, x minus h, then y minus k. So ang imong k is equal to r. So from initially there are 3 constant, the constant is now reduced to 2. Okay, so if ang akong k, akong himuon nga r, no? So, and take note that my r is fixed, no? Now, kini siyang imuha karong coordinates dire, no? If you take it as minus r only, then it's only the circle above that is considered, no? Being fixed, no? Because it will only assume one value. Now, if you want to include the other one, which is really part of the condition of the problem, so you have to indicate the plus and minus. That is, if your r is fixed. But if it's arbitrary, then there's no need to put really plus and minus because arbitrary can either be positive or can be positive or negative. Okay, so in this case, we need to show that there is plus and minus because there's a point, there's a circle above x and there's a circle below to include. Okay? So, continue. How many arbitrary constant do we have? So, there's only one, no, constant, arbitrary, because the other constant, which is r, is already at a fixed value. So, I need to differentiate, no, only once. Okay, so, eliminating h, okay, by differentiating, okay, so 2 times the quantity x minus h, no? So, we have plus, we have 2 times this quantity, reduce the power from 2 to 1 and take the derivative of this, which is y prime. Okay? So, unsa may nawagtang? Wala. No? So, h and r are still there. We are supposed to eliminate h. So, I can solve for h. I'm not allowed anymore to go with further differentiation. Why? Because ang ato karong pag-differentiate is governed with the number of arbitrary constants. So, doon na ako'y first derivative. So, I am not allowed anymore to go with further differentiation. Now, h is to be eliminated. So, I have to find a way to eliminate my h. So, I try to solve for h out from this equation. So, if I'm going to bring my h there, then x plus this term is the value of your h. And this is equation number 2, where I can go back to my equation 1. So, I can replace my h with this one. Okay, so what is the resulting equation? Okay, equation 1, equation 2. In the next slides, no, akong collect. Okay, and then I substitute, no? So, x minus, this is your h from here. Then plus, okay, there's a quantity, y plus minus r. But there is r squared in the other side. So, it's good to expand this to eliminate your r squared. Okay, so x and x are out. This is supposed to be a negative quantity. However, if you take the square, then this term is now converted to positive. No? So, I may have a product between them, taken and square, okay, plus the y squared, no? Plus minus 2ry equal to 0 after removing your r squared. Okay, so that is your answer, an equation in first order. So, if you have a parabola with vertices at the origin and foci at the x-axis, so that means that your parabola will actually open to the right or to the left. So, you know the equation of the parabola that opens to the left or the right. So, you have the option of not showing anymore the graph of your parabola. Okay, so, okay na ni. Now, wala na laing constant except for a. The plus indicates that the parabola will open to the right, and if that is minus, the parabola will open to the left. But just to show the members of the family of curves or parabolas, no? So this is how your parabola look like. No? So there is, if this is the focus, no? So there is a different length of the opening of your curve right at the focus because your A or your 4A is actually an arbitrary constant. So the focal width will actually be different. Your A is the distance from the focus to the vertex. No? So the parabola now can open to the right or to the left. I have to eliminate A. Okay? So you can differentiate directly, or I choose to isolate my constant by dividing with x both sides. No? I associated my 4, the plus minus, with A, plus minus 4 to A, because this is still a product of constant which is still an arbitrary constant. By the way, the plus and minus sign here, no? Dili siya necessary nga imong ibutang. But if you're going to put, it's okay. Anyway, ma-eliminated maghapon siya. No? So, manang okay ra, basta arbitrary, pwede rag ibutang, pwede rag di. O imong ibutang, so no problem. Anyway, ma-eliminated maghapon imong term. Okay, so I can follow the quotient rule. Okay, so we have x squared, we have x with the derivative of y squared, and y squared, the derivative of x, which is 1. We can multiply with the LCD, that is why the x squared is out, no? And the resulting equation are the terms coming from the numerator. But notice that your y is common, that is why this is reduced by dividing with y. So we have 2xy prime minus y. So y prime, we know that is dy dx. To convert that into a differential form, so I can start with y dx and I take it as a negative term, no? So pareho rag akong ibailhin dito spikas or akong i-multiply og negative 1 to start with a dx term, which is the usual arrangement in the first order, first degree differential equation. One last problem in parabola. Now, if you need to recall the equation of the parabola, akong ibutang dire. So these are the equations of the parabola that opens upward or downward. It is x that is in quadratic form, no, or in second degree with vertex at a location of its k. So if you have to interchange ang y maoy na second degree, then the parabola will open in a direction of either left or right. Left when it is negative. Now 4a is the focal length or the length of the latus rectum. Okay, if the vertex is at the origin, then h and k are 0. Then we can modify the equation. We can take the same orientation of our figure. No? So A is the focal distance. It defines the distance from V to F. Vertex to focus or vertex to the, this is directrix. No? Nasayop ko. This is vertex to the directrix. 4A is the latus rectum. No? Or the focal width. Okay, parabolas. Okay, next problem. We have parabolas with axis parallel to the x-axis. Okay? So, if you say that the parabola has an axis parallel to the y-axis, then the parabola will open upward or downward. Because the axis of the parabola is the axis of symmetry of your figure. And with a distance from the focus to the vertex fixed as A. So that means the focal width will also be the same. No? The opening of your curve right at the focus will be the same. Okay? So, solution. So, we may have the figure. No? So, the parabola will open either downward, no? Upward, no? And if this is your focus, kung nung mong focus, so the opening of your curve are actually the same. What would be the equation of the parabola that opens upward or downward? So, I can use this. Okay, so we have a parabola that opens upward or downward. And take note that your A is fixed. So if your A is fixed, no, then it would be necessary to indicate the plus and minus. Because if you have to use plus only, then the parabola will only be purely going upward. No? To include the parabola that is opening downward, then you can assign the negative, no, part of your 4A or your A. Okay? So, arbitrary are hk and your fixed constant is A. Okay, so I have to eliminate my hk by differentiating my equation 1 twice, now with respect to x. Okay? For the first time, differentiation is done. I was able to eliminate my k because k is isolated. So, 2x 2 times x minus h, then plus minus 4a, derivative of y is y prime. Okay, simplifying by dividing with 2. So I have x minus h, and it's good because h is again isolated and h needs to be eliminated. So differentiating with respect to x, x becomes 1. This is eliminated. And we have plus minus 2a, then y double prime. So if h and k are totally removed, and I arrive with the order of the dA which is in second order, then this is already an answer to your problem number 6. Okay? So that's the last problem in the dA of the family of curves. Okay? So thank you for watching and good day.